If you have used Fetch outside of a pet project, you know that it lags a lot. And what you end up doing is either creating your own client on top of Fetch or creating small utility functions for everything that Fetch doesn't provide a clean interface for, or an interface at all. So you end up using something like Axios. But the problem with those libraries is they still lack a lot of features. What if you need telemetry? Well, you need to do it yourself. What if you want custom retry policies? Because as far as I'm aware from all of the options that I researched, they usually limit you to a specific type of policy. So for example, only exponential policies or spaced retries. But what if you got rate limited and the server sends you a header telling you retry after X duration? Well, most of these libraries do not support that at all. So again, you have to do it yourself. What if you want runtime validation? You need to install a third-party library for that. So you end up bringing SOD, Valibot, whatever it is. And again, you need to hook it up all together by yourself. What if you want a platform agnostic implementation? Maybe Fetch isn't supported in X environment, or maybe you need to use XML HTTP request. Well, again, most, if not all of these libraries do not support this agnosticism. So you end up installing different libraries depending on the environment. And finally, what about interceptors? Well, most modern HTTP clients do support interceptors, custom clients, etc. But most of the times they aren't truly composable. They are quite limiting. So for this, I want to introduce you to a very powerful library that supports all of these within the same ecosystem. So the API is very uniform and the developer experience is really, really good. And that library is called Effect. Now, if you have no idea what Effect is, make sure to check out my channel. I have a ton of videos on it. Now, I'm not going to introduce you to Effect in this video, so make sure to open up the documentation, play with it for an hour or so, and then come back to this video. Or you can watch the whole video, and if it looks powerful enough to you, then you can start learning Effect. Anyway, for this, we're going to need the Effect core package. So this one, and we're going to need the Effect platform package, which is the one that ships the HTTP client module. Now we will also need the platform specific package if we want to play around with different live implementations. So for example, the platform browser 1 or the platform node 1, but they are not strictly necessary. So if you want to go along with me, just make sure to have all of the libraries installed. Okay, so first things first, let's create a program. So const program is equal to Effect.gen, just so we can start yielding stuff. So for this, we can now say HTTP client is equal to yield and then HTTP client.HTTP client. And this comes from Effect platform. Now what we're doing here is targeting a tag, which is Effect speak for an interface. So this is not the actual implementation, this is just the interface that all live implementations of this client will actually provide. So as you know, what you basically do with dependency injection. And so by doing this, we get back an HTTP client, as we can see here. And now program does not succeed with anything, will not fail with anything. However, it will again require the live implementation for this client. But let's move on from this. Let's say we want to make a GET request. For this, what we can do is say HTTP client and then .get. And this right here is going to return an effect. So notice how it is a function. First argument takes in the URL, which is a string or URL. And then we have the options. And this one right here is no body. And that's because by convention and the standard, method, a get request shouldn't have a body. And this is going to return to us an effect that is going to succeed with an HTTP client response. It is going to fail with an HTTP client error, which actually encompasses two errors, the request error. So let's say you have no internet connection, and then the response error. And it is not going to require anything. Now, if you're using the effect language service, you're going to get an error here saying effect must be yielded or assigned to a variable. And this makes sense because effects are lazy, they are not eager. And get returns an effect. So what we can do here is say const response is equal to and then yield. And so we're going to basically flatten this effect and we're going to get the HTTP client response here. And we're going to propagate the errors and the requirements over to the parent. As we can see, program now fails with HTTP client error. However, we can still handle the errors here. So how can you handle errors? At least at the basic level. Well, for that, you can use the effect combinators. You can use effect.catchall, catchtags, etc. But since this is a library within the ecosystem of Effect, then the convention is to use catchtags. And here we get access to request error and response error. So now, for example, we can say if we get a request error, then we can succeed with something else. So for example, with undefined. And now we're going to get HTTP client response or undefined. And you can do the same for the response error. But now how can we interact with the actual response? Well, for that, let's try doing response.json. What are we going to get back? We're going to get back an effect that succeeds with another effect. And this effect succeeds with unknown, fails with response error, and does not require anything. That's because response.json is an effect and it is properly typed. So as you can see, it is going to succeed with unknown as opposed to any. So what do we need to do here? Well, we need to yield it. So we need to say JSON is equal to yield. Now this is not a function, this is an effect. And again, effects are lazy, not eager. So that's why it's fine for the JSON property to not be a function. Now, why does it fail with response error? Well, because it could fail deserializing the JSON. Maybe the server responded with something else. So again, this will be represented in the error channel. Now, how can we validate the JSON body? Well, for that, we can use effect schema. So one way to do it is to import schema and say class to do extends schema and then class of to do, and then we can define the properties like this. Or you can use the schema.struct variant instead, but this one gives you an opaque type out of the box, meaning that it is both a runtime value and a type alias. And then with this, we can say to do is equal to yield schema.decode unknown. Then we pass in the schema and then the JSON back. And as we can see, we're going to get back a to do here. If this were to be a schema.struct instead of a class, then you would get the actual structure type instead of this to do alias. And then you can return the to do. However, this is very imperative. We need to do it step by step. We need to say yield response.json, then yield schema.decode unknown, pass in the schema, and then manually pass in the JSON. And finally, we can return it. So one alternative is to use the combinators provided by the HTTP client response module, which, as any combinator does, it allows you to have composition as well. So what I mean by this is we can turn this into a pipe, and then we can say effect.flatMap, and then we can say response.json, or we can say HTTP client and then response and then .schema.json or HttpClientResponse.schemaBodyJson. In this case, this is for the body, so we say HttpClientResponse.schemaBodyJson, and then we pass in the schema like this. And as we can see, we get a to-do here. Now we do flat map because this returns an effect. So as we can see, effect here. So now we can get rid of this line and of this line as well. So we get the to-do here. And now this is redundant, so just return yield. And as we can see, what we're going to get back is an effect that succeeds with to-do. It is going to fail with both request error and response error, and it is going to fail with parse error. So there was an error decoding and validating the body. And finally, again, it requires the HTTP client. Now let's say you want to create your own combinators for HTTP client response. How can you do that? Well, for that, let's recreate the schema.body.json. So let's say const schema.body.json, and then here we take in the response, which is an HTTP client response. And then here we can say response.json, and then a pipe, and then flat map, and then schema.decode unknown. And then you can take in the schema here. And for this, we can say this will be generic, so preserve the decoding, encoding, and the requirements, and then pass it here. And we can use this schema instead. And now we can replace this with our own combinator. However, we can make this a data last approach, so the current version. So here we can say response, and we can get rid of this parameter here. And as you can see, we now get a to-do here. So this is how you can create your own reusable functions that operate on responses. Now, what about making a post request? Well, for that, same thing. We simply say HTTP client and then .post. And now here we can pass in a second argument, and we can say body, for example, or you can even pass in headers or URL params. So for this, let's go with body. Now you might try doing this right here. So you pass in a raw object. However, it expects you to pass in an HTTP body. So what is this HTTP body then? Well, let's import it from Artifact platform. And as we can see, we have a lot of helpers. So we have a file, we have a file for web, we have form data, and we have JSON, and we even have raw. So just send the body as raw, do not try decoding or validating anything. So let's go with the JSON. If we do this and then pass in the actual JSON object, as we can see, we get an error here saying type effect is not assignable to type HTTP body. And that's because JSON returns an effect. So we need to yield this, and now it works. So why do we need to yield this? Well, because this is an operation that can fail, and it is going to fail with an HTTP body error. And that means it is an actionable error, so you can recover from it. You can do whatever with it. This is useful for when you dynamically create a request and you maybe want to let the user know like, hey, whatever you passed in is not serializable to JSON, or if it's in the context of an API, maybe you're generating requests with GPT, then you can use this information here to retry the operation, for example. Anyway, most of the times you're not going to do this the effectful way. So for that, you can use unsafe JSON, and it is like any other function. It is not effectful. Now this is going to throw an error if it cannot serialize the body to JSON, but that's going to be translated over to a defect. And so now with this, as we can see, we get the response here. That means that we can pipe through this and say effect.flatmap and then HttpClientResponse.schemaBodyJson, and we get back a to-do. Great, so now let's take a look at how we can compose requests. So we have already seen that we can compose, or rather operate on HTTP client response using the HTTP client response module. Well, Effect has the same thing but for requests. So we can say HttpClientRequest. And now, for example, we can say .post, and this will succeed or just return an HTTP client request, as opposed to this one. Notice that the HTTP client.post will return an effect that succeeds with the response. So here we can compose requests. So now we can pipe through this, and we can say HTTP client request dot and the bearer token, and we can say 1, 2, 3. So notice how bearer token takes in self, which is HTTP client request. So this is the hurried version of this function, and you can say HTTP client request dot headers or set a header, for example, and the effect will start composing everything. Now, what about the body, for example? So HttpClientRequest.Body. Well, we can use setBody, and then we can say Unsafe JSON, but you cannot do JSON because this is an effectful computation. So if you want to do this, you have to lift it up, meaning that you would have to do it first and then pipe through it, and then do an effect.map, and then start composing everything, or be inside a generator and yield it here, like this. Now you might be wondering, but how is this useful? Why do we want to compose it like this? When calling post, for example, you can pass in everything as options right here. Well, that's a completely valid question, and the reason for that is because it enables composability, meaning that it is super straightforward to have a function taking a request and then you compose it internally. So you can compose it both when consuming it and internally in the function, as opposed to this right here. So for example, if you want to say const compose request and you want to do this post right here, then you need to define the arguments for accept, accept JSON, hash, etc. Instead, what you can do is say request, HTTP client request, and now you can pipe through this request and add a bearer token, for example. So this could be called a request with bearer token or just with bearer token. That way you can come here and say with bearer token, and now you are composing it in a very nice and elegant way, which wouldn't be possible with the other API, or at least it would be super clunky. And you can add more stuff here. So you can set a header, so that header and then API version, and none of this obviously leaks into the consumer. But now how can we execute this request? Because we have an HTTP client request here, but we know that when calling post, it does not take an HTTP client request. Well, for that, we can say HTTP client and then execute, and this takes in the HTTP client request. So we pass it in and we get back a response, as we can see here. So as you can see, it offers both APIs. So it offers the Axios-like API, where you can say post, put, delete, etc. But if you need to compose your requests, then you can use execute instead. Okay, great. Now I assume this is giving you ideas, and that is how to build a composable client. So you might be tempted to create a tag where you expose a method that takes in a request. So the client can say they want to do a post request to this URL, but this function internally adds this with bearer token and some other utilities. Now that could be one valid approach, but you can actually apply combinators on the HTTP client directly. So all you need to do is compose it here, and now whenever you say HTTP client.post, it will set the bearer token, the API version, etc. So for this, we can come here, wrap this in parentheses, and then we can pipe through it. And we can use combinators such as mapRequest. And this is a function that is going to take in the HTTP client request. So here you could say with var token, or more commonly, you can say request and then pipe it here. And then you can do this right here. So now we can get rid of this utility. And now all requests made via this HTTP client will have these two headers. So the var token and the API version. Now this right here applies a transformation, and more specifically a pre-processing operation, where the intent is to modify the request before it's sent over the wire. But these pre-processing operations might require asynchronous operations. So maybe we need to read the token from somewhere. How can we do that? Well, for that, we can say mapRequestEffect. And now here, instead of returning the request, we must return an effect that succeeds with a request. So we can say Effect.gen, or you can come here and say function, and then the generator here. And now you can pipe it through. So here you could, for example, have the token ref and then ref.make, which will be a string, and then we can say token, and we can pass it in as such. We then also have the mapRequestInput combinator, which same thing, takes in the request here, and you can apply other combinators here. But what is the difference between the two? Well, let's take a look at the docs. So here, mapRequest says appends a transformation of the request object before sending it. Notice the appends. And for the mapRequestInput, it prepends a transformation. And it also has the Effectful variant. So what that essentially means is that if you have a pipeline of multiple transformations for the client, so let's say you have multiple sequential mapRequestInput transformations chained, then the last one effectively becomes the first one to be executed, while mapRequest is added to the end of the current pipeline. Now, what about the post-processing, meaning that we operate on the HTTP client response? Well, for that same thing, we say transformResponse, and here, as we can see, we must pass in a function. So let's come here. We must pass in a function that gives us an effect, and this effect right here will succeed with the response. And then it preserves the error and the requirements channels. And what we return back is a new effect with the response and then E1 and R1, meaning that we can further process the response. We can modify the error channel. So maybe we can implement custom error handling or even retry logic, and finally require something new. So what that means is that we can come here and say Effect.retry, and then we can say do this spaced every second for 3 times. And we can say while the error tag is equal to a request error. So we're applying a retry policy for all requests made with this client for basically transient errors. Now this is one way of doing it. The other way is to say HttpClient.retryTransient, which basically does the same thing. And we invoke it here. And we can pass in times and the schedule and even a while. And what is this doing internally? Well, let's come here to internal.retry-transient. And as we can see, it does a transform response, same as we were doing. So it takes in self and then the function, so effect.retry, and it checks for is transient error, and it also uses the predicate module to do an OR. So is transient error or the one that we pass in. Super clean, and this is a great module that I should make a video about. and then the schedule here and times. And that's it. Now all requests will use this retry policy. Okay, so now let's take a look at how we can use transform response to remap errors or to derive a new error from the response. So for this, I'll use Cognito as an example. So in Cognito, whenever there's an error, it is going to respond back with a header. And this header is the X and then Amazon error type. And this one will have all of the errors like this. So with a colon. So limit exceeded exception, colon, etc. So what I did was define all of the base errors that I will hold in my actual runtime error without the colons, and then I defined a schema that maps over each error, adds the colon as defined per Cognito, and then I applied a transformation to decode them and remove the colon, so we get the errors like this. And this is just for the developer experience, so you do not have to match against the errors with the colon. And then I defined the schema. So I expect the response headers to at least have this property. And I then rename this property to just error type, again for the developer experience. And then I defined the tagged error. So here extends schema, or this could be data, and then tagged error. And then this would be of type error without colon. So like this. And then in my HTTP client, I get the access token, though in this case we wouldn't have an access token since it's for Cognito, so to authenticate the user, and this is unnecessary. And then here I apply a transform response where I grab the headers from the response, I decode those headers using this schema, and then I match this either. So on left, so if there was an error decoding the headers, then I succeed with the response. Though here you could cause a defect or whatever you want. And then on the right, I create a new Cognito response error, and I pass in the error type. That means that HTTP client now fails with an HTTP client error or a Cognito response error. So if I have a computation, which is simply HttpClient.get, as we can see here, this is an effect that again succeeds with the response, but fails with HTTP client error or Cognito response error. So now we can apply an effectful combinator, so catch tags, and then we can do something with this error right here. So as you can see, it is incredibly powerful. It maintains the error channel, the requirement channel, everything, so any consumer can have all of that information. Really, really elegant. Now, how can you create a reusable client where you can access it anywhere you want? Well, for that, we can say plus Cognito HTTP client, and this extends effect, or we can use context.tag, and then we pass in the shape. So what this is going to hold. In this case, it's simply HttpClient.HttpClient. Though for future proofing, so you do not have to refactor everything if you want to add something else, I would advise using an object instead. So read only HTTP client. And that's it. And then you can have the const make Cognito HTTP client, which is just a generator, and you yield this, and let's actually copy this right here. So let's come here and paste it here and delete this, and then we can just return the HTTP client, and we can say as const to make it read only, and instead use effect.effect.success and then type of Cognito HTTP client, and then we can attach the live, so read only live is equal to, and then layer.effect for what tag for this one, and then make Cognito HTTP client. And this is actually a static property, and that's it. Now you can provide it, so you can say HTTP client is equal to yield Cognito HTTP client, and then you can say effect.provide Cognito HTTP client.live. And as we can see, program just requires the HTTP client implementation. Now, before looking at how we can provide the live implementation for the client, let's take a look at how we can have a cancellation, which is super straightforward. So let's say we have a Fiverr running a request. So this one right here, and we want to apply a timeout. Well, all we need to do is say Effect.timeout and then pass in a duration, so 5 seconds. And that's it. This timeout right here will interrupt the Fiverr, meaning that the underlying client will likewise interrupt the request. And that's it. That's all you need to do. Obviously, this is going to add the timeout exception to the error channel. So now look at this. We have HTTP client error, Cognito response error, and timeout exception. This means that we can also add a timeout policy to the client itself. So we can come here and say transformResponse and then Effect.timeout. And that's it. Now we can get rid of this here. And as we can see, program still fails with timeout exception. Now, what about providing the actual client? So this far, we have seen that program has always required the HTTP client. Now, that's because this is the tag. This is the interface. So you need to provide a concrete implementation. So regardless of the environment, all of your logic stays the same. All you need to do is come here to the root of your whole application, whether that's a layer or in our case an effect, and then provide it here. So there are different clients that you can use depending on the environment, but the first and most straightforward one would be the fetch HTTP client, which comes from Effect platform. And then we can say .layer, and this is a layer that is going to succeed with an HTTP client. And this one will use the global this.fetch. So you can use this in browser environments and Node.js versions that support fetch globally. Now there's also the Node client or the Node HTTP client.layer, and this internally will use, and actually let me revert this back and duplicate this instead. And so we can say Node HTTP client.layer, and this one will use, if I'm not mistaken, the built-in Node HTTP and Node HTTPS modules. And you also have under the Node HTTP client one, the layer OnDC, which uses the OnDC library, which is known for high performance. And what about browsers? Well, for that, we can say either fetch HTTP client.layer, which has fetch, or if for some reason you need to use XML HTTP request, then you can say browser HTTP client and then layer XML HTTP request. And if I come here to this layer, just so you get an idea of how this works, you can see that it succeeds with make XML HTTP request. So it adds the event listeners and uses effect.async for all of the callback style APIs. And that's it. Those are the 4 ones that Effect platform and their specific platform packages support. I may be missing some, but you can check it out. So this is all that you need to do. You simply do effect.provide or layer.provide and then pass in the corresponding layer. And I forgot to mention one thing, and that is filtering statuses. So by default, it is not going to check against 4xx errors or 5xx errors. So for that, what you need to do is in your client, say HttpClient.filterStatusOk, and this will simply apply a filter. So as we can see, transformResponse, Effect.flatMap, and then filterStatusOk. So it checks that it's between 200 and 300 non-inclusive, and if so, it succeeds with the response. Otherwise, it is going to fail with a response error, which as we can see, it passes in the response itself, the request, the reason, and a description. Okay, so now let's say you want to apply a Retry-After policy. How can you do that? Well, for this, first of all, I have this mapRequest computation. It is an effect that again succeeds with a client response, fails with request error or response error, and finally requires the live implementation. So here I simply target the tag, then I pipe through it, and then I get this service and call service.get. And we need to flatten this because, well, this is a tag, so it is effectful, and likewise with this returns an effect. And then I defined the schedule. So schedule is a very powerful module that is composable and has a ton of combinators and utilities so that you can, for example, apply exponential retries or spaced retries as we saw earlier, or well, in this case, derive a delayed schedule of the response headers. So for this, we need to say schedule.identity and then we pass in the type. So what we're expecting here. As we can see, if I hover over this, the input is unknown, so it can take in anything. And identity is simply a way to create a schedule that passes through its input as its output, so that we can then map over that error, for example. Now, in the context of effect.retry, when you pass in this schedule, retry will give the error of the effect as its input, basically. So here we're passing in, again, the HTTP client error. And then we can map over it, and we can use option to make things more declarative. So we can say lift predicate, we pass in unknown error, which would be self, and then we pass in the refiner, so the refinement function. And here we simply check that it's an instance of response error. That way, if it is not an instance of response error, then it is going to be none. And if it is an instance, then it will be sum of response error. And then we can pipe through this option. We can apply the flat map combinator. Why? Because we're using duration.decode unknown, and this will return an option. So if it was able to decode it, we get it in the sum. If it failed to decode the duration, then it will be a none. So that's why we do a flat map, to flatten this nested option. And here we simply extract from the response headers the Retry-After header. And if we got a none for some reason, so maybe this was not an instance of response error, or we weren't able to successfully decode the Retry-After header, then we simply fall back with duration.0. So basically no delay. And then you can add a top output where the output would be the delay in this case, so the duration. And finally, you can say schedule.delayedSchedule. So this transforms a schedule outputting a duration into a schedule that introduces the delay. And that's it. Now you can say make request and then effect.retry and pass in this schedule. So now if you want to apply it to your client, so all consumers get the same retry treatment, then you can create your class. This time I'm going to use effect.service instead to reduce some of the boilerplate. Now, if you have no idea what Effect.service is, make sure to check out my video where I go over Effect.service, Effect.tag, and Context.tag. Anyway, here we yield the client and then we can return an object where we simply compose the HTTP client and do a transform response and then Effect.retry. And with this, we can now say main and then yield my client. So now main requires my client. And now if any request fails and we get our Retry-After header, it is going to apply this delayed schedule. Now, if you know that there are only select endpoints that use this Retry-After header, then you could leave your main client like this. So you could say HTTP client, or rather compose it here. So pipe and then effect dot or HTTP client mapRequest and then HttpClientRequest, and then you could say Prepend URL. And so you expose this HTTP client as is, and then you could say client with Retry-After, and then you pipe it through, same client, you're composing the same thing, and you add the transform response, and that's it. Now you can say client and client with Retry-After, and well, you can consume whichever is needed. And that's it. I hope this video helped you demystify the HTTP client from Effect. And if you want to see more content like this, make sure to subscribe and like the video. I'll see you in the next one. See ya.